welcome to Special Triangles. We're going to look at 30, 60, 90 triangles and 45, 45, 90 triangles today. So if we have a triangle like this that has a 60 degree, 30 degree, and 90 degree angle, okay, there's some special characteristics. Think about what would happen if we reflected this. If we flip this triangle like this, then this side would be 2, and this would be A, and this would be 60, and this would be 30. Now the interesting thing is what happens here. This angle is now 60, which makes this triangle an equilateral triangle. So all the sides have to be the same. So if this is 2 and this is 2, then this has to be 2, which makes the A part 1. So we have this 30, 60, 90 triangle now that has 2, 1, and we got to figure out B. So we could use a squared plus b squared equals c squared to figure that out. 1 squared plus b squared equals 2 squared. And that's going to be 1 plus b squared equals 4. So b squared equals 3. So square root that is positive or negative, but we can't have a negative because it's a length here. Square root of 3. So in this triangle, 30, 60, 90, remember when you have 30, 60, 90, we have a big leg, a longer leg that's opposite the 60, a short leg that's opposite the 30, and the hypotenuse. And we see this kind of relationship start to happen. Okay, there was another problem. What about, why, thank you. What about something like this? If we flip this one, now we've got 60, 60, 60, so this is 8, this is 8, this is 8, which means this part has to be 4. And then to figure out the height here, we'll call this b, that's fine. We've got b squared plus 4 squared equals 8 squared. So that's going to be 48. And if I square root that, we've got square root of 48. We could make that a little smaller. 48 goes to 6 and 8, 4 and 2, 2 and 2, 3 and 2. And now we can look for pairs. Here's a pair of 2's. Here's another pair of 2's. Here's a leftover 3. So this is 4 square roots of 3. So we have 8, 4, and 4 square roots of 3. There's another problem that we worked on that looked like this. What if we have it like this? Well, look at the relationship here. Every time we've got the short leg and we've got the hypotenuse, you notice that it's double and it's double. So I guess if this is 15, it would make sense for this to be double. And then if we did Pythagorean theorem, if you worked it all out, you'd end up with the square root of 675. And that reduces and breaks all the way down, and you would end up with 15 square roots of 3. I did that fast because I don't really care about taking the time for that. I care about you looking at the pattern. Do you see the pattern we have here? This is the short leg to the hypotenuse is doubled. From the short leg to the long leg, we just multiply by square root of 3. 4 square roots of 3. 1 square roots of 3. So we have this special triangle that has, every time we have, here's my 60, my 30. Let's say this is A, that's my short leg. The hypotenuse is always going to be double that, so that's 2A. And the long leg is always going to be whatever this length is times the square root of 3. So if we have 15 here, double, and then 15 times square root of 3. Thank you, thank you. I tried. Good. The other kind of triangle that we need to look at is 45, 45, 90. And this one's even easier. Because this is an isosceles triangle, right? So if this leg is x, then this leg also has to be x. Good. And then the hypotenuse, we'll call that c for right now. That would be x squared plus x squared equals c squared. So this is 2x squared equals c squared. And then to get c by itself, we need to take the square root of both sides. And here, these parts are being multiplied together. you're allowed, whenever you have something multiplied together, you're allowed to split that up. Square root of 2 times square root of 3 is the same as the square root of 6. That's okay. So if we have this, we can split that up into square root of 2 times square root of x squared. And the square root of x squared cancels and just leaves x. So this is x times the square root of 2. So over here, whatever that leg is, if we multiply it by the square root of 2, that will always give us the hypotenuse. So we've got x, x, and x square roots of 2. So here's our 30, 60, 90. Here's our 45, 45, 90. I'm going to make this a little better square root symbol here. Oh, that was terrible.
It's okay.
There we go. So now we can look at some example ones. This first one's really pretty easy. They give us the short leg, which is like the A. So to find the hypotenuse, all you have to do is double it. So this is 20. To find the long leg, all you have to do is multiply it by the square root of 3. So this is 10 square roots of 3. Done. Thank you very much. 45, 45, 90. If one leg is 4, the other leg also has to be 4. And the hypotenuse has to be, everybody knows it now?
3. Yes.
Square root of 3.
4 to the square root of 3.
4 times the square root of 2. Don't clap until you get it right. First get it right, then clap. Okay, on this one, it's 45, 45, 90. But we know that to get from the leg to the hypotenuse, we would just multiply by square root of 2. So what do you think we have to do if we're going from hypotenuse to leg? Divide by square root of 2. So to get from here to here, we just take 8 square roots of 2 and divide by square root of 2, which is 8. 8. Okay? Now the next problem is probably the most tricky one of all. Because what they give us here is the big leg, not the short leg. Now to get from short leg to big leg up here, we would take A and multiply it by square root of 3, right? So to go from here to here, we would need to divide by square root of 3. So you take the big leg of 9 and divide by square root of 3. Oh, but wait, we can't leave a square root in the bottom. We've learned that, right? So we need to rationalize the denominator by multiplying by 1. So it looks like this. And that is 3. And this is 9 square roots of 3. And here we can cancel the plain numbers. Dividing, that makes 3 square roots of 3. So this is the big leg. The small leg is 3 square roots of 3. And the hypotenuse is going to be double the small leg. So if we double this, that's 6 square roots of 3. Here, they give us the hypotenuse. So how do you go from hypotenuse to small leg? Divide it by 2, because that would be 2a going to 1a. So dividing by 2 would be 3. You're going to be famous now. And then from small leg to big leg, what do you have to do? What do you have to do to get from small leg to big leg? Times the square root of 3. Great. So this is going to be 3 times the square root of 3. Last problem. Here's the hypotenuse in a 45, 45, 90. What do you think you have to do to get from hypotenuse to leg? Divide by square root of 2. Some people could be coordinated enough in this class to walk. Okay? So now we got to rationalize the denominator. That makes 2. And this is 6 square roots of 2. If I divide these, that gives me 3 square roots of 2. So the leg is 3 square roots of 2. The leg here is 3 square roots of 2. That's how you do it. Have a great day.